So the first thing you should have done is you should have tried this launch problem. If you and your group haven't tried the launch problem, I'd like for you to go ahead and pause the video, and then you're going to go ahead and try the problem. Just read it, try and decide how you would solve this problem given the information in the table. When you and your group have all decided on who you think is the turtle that will win the race and how much they will win by, then go ahead and unpause this video so that we can talk about your strategies. Okay, now that you've finished, I want you to go ahead, check your answer in digits, and just see whether your strategy matched theirs. Once you have filled in this question and the question underneath about could you solve it without unit rates, you're going to go ahead and unpause. You're going to pause the video and you're going to look at part 1, the key topic and the key notes within digits. You should have one computer open to Realize and one computer open to this video so that you can go back and forth as a group. So let's go ahead and look at the first video, the first part in digits. So it is first starting with talking about a rate. And so you will need to fill this in your note packet so that you remember that a rate is simply a ratio. And remember that we can write ratios as fractions, we can write them using the word to, or we can use colons. For this lesson, when we're talking about rates, we usually want to write it as a fraction. It makes it a lot easier. In order to be a rate, it has to have different units. So I'm not going to have 3 feet over 6 feet. They have the same unit. That would not be a rate. So when we talk about rate, if I'm saying 3 feet per 2 hours, that would be a rate because I'm comparing feet and hours. So a rate is a ratio that compares quantities. Remember, quantities are simply numbers measured in different units. A unit rate is when we take a rate and we divide it down until it's 1 unit of a given quantity. So when a unit rate is written as a fraction, the denominator is 1 unit. Remember that denominator is the bottom part of a fraction. So think for a second, what's the top part called? If you're remembering that that's a numerator, you are correct. Sorry, my little pen sometimes doesn't write as well as I want it to. So when we look at our problem, you are often given a rate such as this. If a car travels 120 miles on 4 gallons of gasoline, we would write that as a rate. We're going to go ahead and put 120 miles on the top and 4 gallons on the bottom. That would be my rate. If I just said write the rate, okay? The unit rate, on the other hand, has to have a 1. It has to be per unit. So in this case, we want to know what is it per gallon. So think about what you did last time about writing equivalent rates. So I'm going to go 4 gallons to 1 gallon, To get from 4 to 1, I have to divide by 4. In order to keep it equivalent, whatever I do to the bottom, I also have to do to the top. Because 4 fourths is equal to 1, so I'm just changing the name of the fraction or of the rate. So 120 divided by 4 would give me 30. 30 miles per gallon. So that means, looking at my picture, 1 gallon will get me 30 miles, 2 gallons will get me 60 miles, 3 gallons will get me 90 miles, and 4 gallons will get me 120. So the unit rate can help me decide how many gallons would I need to go 150 miles. How many gallons would I have to have in order to go 210 miles? So finding the unit rate is really helpful when I'm trying to figure out a different equivalent ratio to my original. Okay, so if you have this, what we're going to go ahead and do is I want you to look at the first example. So go ahead in your packet. It says a lobster molts or sheds its shell 20 times over a period of 5 years. Sorry, my dog is squeaking his bum. And so what I want you to do first, you're going to circle the important numbers. You're going to underline the rate, the unit rate that you're looking for. Okay, so you're looking for the keyword per. So you're going to underline the key clues. And then I want you to try and write the original rate. Okay, when you think you have that, you're going to unpause me. Okay, so go ahead and pause. And then when you're ready, so you should not unpause until all of you have circled the important ideas and think and underline the keywords and think that you have written the rate correctly. Okay, so it should be paused. All right, now go ahead. I'm assuming you have it done, so let's look and see what you have. So it says 20 times. It sheds its shell 20 times over a period of 5 years. How many times per year does the lobster molt? If you did not underline and circle what I did, I want you to go ahead and circle and underline. That's going to be the key to making this a lot easier. So I want per year. So I want my unit rate per year. So I'm going to put year on the bottom. On the top is the number of times it sheds its shell. So now I'm going to write my original rate. So 20 times over 5 years. Okay, now we have the original, and now we want per year. Go ahead and pause me again and try and figure out how many times per year as a group. When all of you have it, unpause. Okay, so at this point, I'm ready to divide it. To get from 5 to 1, I'm going to divide by 5. Whatever I do the bottom, I have to do the top. Whatever I do the denominator, I have to do the numerator. 20 times divided by 5, is 4 times. So my answer would be, how many times per year? 4 times per year. Okay, easy peasy. Let's go ahead and try the next one. So now, on your own, not with your group this time, circle important numbers, and then underline what you're trying to find. Okay, in this one, it's not as clear what the unit rate is, but it's wanting per minute. Okay, and then when you all have it and you think you're okay, make sure you've showed your work. Don't do shortcuts. Make sure you show your work because it'll make it more difficult later if you're doing shortcuts right now. Okay, go ahead and unpause me when you're ready. Okay, so let's look. We've got 219 heartbeats in 3 minutes. I'm looking for a unit rate, and I want per minute. So minute goes on the bottom, heartbeat goes on the top. So I have 219 heartbeats in 3 minutes. Now, I need the unit rate per minute. So I'm going to divide by 3. Whatever I do to the bottom, I have to do to the top. I'm going to divide that out. 3 does not go into 2 without having a decimal. So I'm going to go ahead and look at 3 goes into 21 7 times. 7 times 3 is 21. I'm going to subtract. That gives me 0. Bring down the 9. 3 times 3 will get me to 9, leaving me with nothing left over, meaning that 73 heartbeats per minute is my unit rate. So at this point, we're understanding unit rates, and now we're going to actually use this in a way that I often use in the grocery store. So when I was younger and I'd go shopping with my dad, he would say to me, okay, be careful, make sure you're getting the best price. And I used to think that because I was buying in bulk, that meant that that bulk price was always the best price. And he said, no. And that's advice I've taken every time I go shopping, because you always want to get your best buy. And so I always look for the unit price, okay? So if I'm going to the store and I want to buy a bag of Takis, do I buy the 2 bags of Takis for a certain price or 1 bag of Takis for a certain price? Because you don't want to always use the, assume that the bulk or the more number of an item is going to be a better price. I'm sorry, my children are distracting me a little bit. Okay, so we're going to move into unit prices. So how do we use unit rates in a way that's actually useful to us? So at this point, you're going to move on to the next part of digits. You're going to try and look at the notes, fill in your notes section for me, and then we're going to go ahead and look at this. It's very similar to what you just did with your unit rates. Okay, so go ahead and fill in your notes, and then go ahead and unpause me. So at this point, you should have, and make sure you're pausing me, okay? This point, you should have the unit price. And you know the unit price is simply a unit rate, but you're dividing down per item. So if I buy Takis and there's 3 bags for 75 cents or 2 bags for 50 cents, I can see that each bag is a quarter in both cases. But what if I can buy 4 bags for 80 cents or 2 bags for 50 cents, okay? Now I'm looking at how much am I paying per bag. So for a unit price, I'm going to put the money on the top, and I'm going to put the unit that I'm looking for, the item I'm looking for, on the bottom. So for example, in your intro, you've got $25 for 4 tickets. The money's going to go on the top. Unless it says something like, how many tickets can I get for $1, okay? Which then I'm going to put the money on the bottom. But in this case, I want to find the unit price or price per item. So I hear per item. That means whatever is per year, per foot, per item is going to go on the bottom. So in this case, I have $25 for 4 tickets, okay? And I always don't shortcut, I'm sorry, my pen, and write your units because it's going to make it easier later. And I want to know, okay, well, how much am I going to pay for 1 movie ticket? Same idea that you had before, but we're going to divide by 4. Whatever I do the denominator, I have to do the numerator. And 25 divided by 4 is not super pretty. I can use 2 strategies to break that up. I can say, well, 24 is a nice number I can divide by. So 24 divided by 6 equals 4, right? So that means 24 divided by 4 equals 6. So if I take out that 24 and say I can get $6, I have $1 left. So 1 divided by 4 is 25 cents, leaving me with $6.25. Okay, that's just using a little bit more number sense. It's me looking at the number and going, okay, I can't divide really quick 25 divided by 4, but I can pull out groups of 4. So 24 divided by 4 is $6. But then I have $1 left over, so I still have to divide that up. That's one way of solving the problem. So one thing I want you to think about is how can you solve problems in a little bit different way? So I could just do the standard algorithm. I could go like this. 4 goes into 25 6 times. That gets me 24. I have 1 left over, okay? So that's that $1 we were just talking about. So I can add a decimal point and add a 0. I bring that down. 4 times what will get me to 10? Well, 2 without going over. 2 times 4 is 8. I have 2 again, so I'm going to add another 0. I don't need to add another decimal point. I always only have 1 decimal point. I bring that down. 4 times what will get me to 20? Well, that would be 5, leaving me with 20 minus 20, which is 0. I bring up my decimal point. So my answer is $6.25 per ticket. Okay? So at this point, you're doing the same thing. You're just looking at unit prices. So you're looking per item. Okay? So go ahead and look at this next one. Your first sample within Digits, within Realize. It says your class is tie-dyeing t-shirts to sell for a fundraiser. You're in charge of buying the plain t-shirts. Which package is the best buy and which package is the worst buy? So for this one, you're looking at, okay, I'm going to have to define the rate per t-shirt. So remember, when you're doing a unit price, the t-shirt or the unit that you're looking for always goes on the bottom and your price always goes on the top. So in this case, you've got 4 different options. So I'd like for you to pause me. This might take you a little bit. And you're going to divide each of these and decide which is the best buy and which is the worst buy. Okay, so go ahead and pause. And when you think that you found it, you can either check your answer and realize, but I should see work for this problem. This one's going to take you a little bit. Don't be afraid to take a little longer on problems, okay? So if I have 39 over 12, remember, I want 1. So that means it's not always going to be pretty. We are to the point in your mathematics that you're not always going to have super pretty numbers. I'm not giving you 36 divided by 12, which would be $3 per t-shirt. So you're going to have to kind of think that through as a group. Okay, so break it up as a group. If you each want to take one and then everyone take a second one to double check, that's fine. But see what the prices are and then decide which is the best buy and which is the worst buy. Once you have your answers here, you should have come up with a $3.25 per t-shirt, $3.15, 3.4, and $2.99, $2.99. Now remember, 3.4 is not $3.04. You would add a 0 because remember, I can add zeros on the end after the decimal point and it doesn't change the value. So when I look at this one, this shirt here would be the best buy because I'm getting it for the cheapest. This one here would be the worst buy. How did you do? Okay, make sure, and it's okay to double check your answers with the calculator, but I want to see your work and I want you to make sure that you're practicing that dividing decimals because that's going to be a key concept that we wanted you to know in 6th grade. And so since you're working on this math too, it's really important that you're practicing that concept. Go ahead and look at the next problem, and I'd like you to go ahead and try that one on your own. See if you can come up with it. It'll take you a little bit. Don't be afraid to take a little bit more time. And then when you're done, go ahead and check your answers and realize. Okay, pause me and then go ahead and check your answers and realize. And when you're ready, go ahead and unpause me. I'm going to move on to the last part. Okay, at this point, you should have finished that last one. And now we're looking at a different type problem. We're thinking of a strategy called a know, need, and plan. So for this section, astronauts have different nutritional needs in space than on Earth, which is really a whole fascinating topic all in itself. But an astronaut's diet contains 18 milligrams of iron for 2 days. How many milligrams of iron should the astronaut's diet contain for 9 days? So I'm going to first put the information I know. I know that there's 18 milligrams per 2 days, right? I need to know, how many milligrams for 9 days. So now I'm going to think of a plan. This is where I'm going to use 2 steps. So I'm going to start with the 18 milligrams per 2 days. And I need to first find my unit rate. So go ahead, find the unit rate. I'll do it as well. If you got 9 milligrams for 1 day, you're exactly right. But I don't want for 1 day. I want for 9 days. So I'm going to go ahead and now I'm going to put 9 days down here. Okay, so now 1 times 9 is 9. Whatever I do the bottom, I have to do the top, leaving that I need 81 milligrams. So my answer is 81 milligrams. Okay, now you're going to go ahead and try that same thing for this. Don't go straight from the 2,272 miles in 8 minutes straight to the 3. You should find the unit rate first. Once you found the unit rate, then go ahead and try. So you should have 3 steps. Write the rate, find the unit rate, and then find the new rate that's equivalent to that unit rate. Okay? Once you have that, go ahead and check your work in Realize. Then make sure you've got all of those notes filled out, and I want you to try the close and check. Okay? So first thing, go through it, make sure that you've got all the parts. Then you're going to go ahead and try that close and check. Okay, so let's go ahead and look at the close and check. In each one of these, you can see that the first one is seeing if you can find per 1 minute. So it's getting into some decimals. So feel free to use your calculator as needed as you get stuck. Okay. Don't be afraid. It's fine to use your calculator. However, it is also important for you to try it and check it so that we can also see if that's something we need to work on. Keep in mind that we're skipping certain things. So when I'm looking at the Earth rotates 125 degrees in 5 minutes, and I want per 1 minute, okay, you're going to get a problem that looks like this, okay? So that means that you're going to have 1 down here, and you're going to divide this by 5, okay? So when you do that, when you're messing around with decimals like this, don't worry about the decimal. Divide it like normal, and then bring the decimal up. So if I'm doing 125 divided by 5, I'm going to do the same process with decimals. The only difference is I'm going to pull that decimal up when I'm done, okay? So if you get stuck on that, and that's something we need to work on, I am totally okay making a lesson on that so that you're feeling successful. Go ahead and try all of the close and check. You can decide which ones you're doing as a team. If you want to try them each as an individual, either one is fine. Work together to make sure that you're doing okay. And then when you're all done, feel free and double check your answers using Realize and see how you did, okay? And then once you've checked your answers, don't just pop up Realize and copy in the answers. Obviously that's not going to help you, and I want to make sure that you're understanding. So when you get done with Realize, and of course I'll be checking in with you, but if you are to that point where you're ready to check it before I come on over, feel free to go ahead and pull up the homework and open up your activity booklet until you're at the page that says workspace for 1.2 homework. Now, I did only include 1 to 3, and I did have a few more problems in there that were extra practice because I cut out 4 and 5. So you'll need to do the 1 and 3, the 2 problems on the top right here as part of your close and check. I just thought those were a little bit better practice problems going into the homework. Okay? Feel free, and remember, use your notes and write things down. I'm okay with you using the little calculator on your computer, or you can use one of my calculators. Here's the calculator on my computer. I don't know, I think it's showing up on yours. Okay. Or you can feel free to go get a calculator from the front calculator caddy. Nice work. I'm excited to see how you did on the notes.